Hello, everyone. My name is Placona. I'm a developer evangelist for a company called Twilio. Does anyone not know what Twilio is here? Cool. So Twilio is a communications API that helps developers like yourselves adding communications into your apps. So those are either the apps you're already building, using the languages you already know, or anything else, really. So we're a RESTful API, and with our API, you can send SMS messages, you can make telephone calls, you can do chat, you can do like communications, you can do push notifications, so anything to do with communications, really. But this is as much as I have to say about Twilio here, okay? The other thing I want to point out is I just recently started writing it's kind of a blog called androidsecurity.info. Some of the information I'm going to be talking about today, you can actually find it on this website. I am going to be publishing the slides later as well, so you can just get the information from the slides. But yeah, I'm basically just writing some of these security tips for Android into this website. Now, and you can also find me on Twitter, you can find me on my email, you can find me on GitHub, so this is, like, you can basically find me anywhere under Marcus Placona or M. Placona. But there's one thing I need to clarify here, which is I am not a hacker, okay? Even though like this whole talk is like I just hacked her up, I am not a hacker. So I am sure that some of you will be way better hackers than I am. Also, the stuff that I do, I'm not really trying to harm anyone, so I'm not really trying to steal information from anyone. The idea, this is like purely for study purposes. So it's just me trying to bring awareness to developers and me trying to bring awareness to companies at how they can actually make their applications a bit more solid and a bit less hackable. But let me just switch the slides real quick here so I can... Good. So even though I just said I'm not a hacker, there's this one thing I really care about, which is security. Like, I really deeply care about security. So most of the things I build, or most of the things I actually get to code review, for example, I will always pick on security. So I will always look at security in a way that most people just don't look at. So one of the things I do, for example, is I hack my own apps. And I hack my friends' apps. And when I do that, instead of just bragging that I actually managed to hack my friends' apps, I tell them, okay, so I just hacked your app, and these are the kind of things you can do to stop. Because obviously, while I just said I'm not a malicious hacker, I'm not really trying to do anything with my friends' applications, there are loads of malicious hackers out there. So I feel like before I carry on, I need to give you a bit of a disclaimer, which is all this. You don't need to read any of this, but the one thing that you really need to pay attention to this is I have not hacked your app, okay? And I say this because the title of this talk is I just hacked your app. So when I came up with this talk, when I came up with the idea of actually giving this talk, I was so excited about going on stage and hacking somebody else's app. And then legal at my company was like, no. Like, you can't go on stage and hack people's apps because companies tend to get suey when you hack their apps, okay? Obviously, it wouldn't be very nice if I came over here and said, hey, I just hacked Facebook. Here's how I did it. That wouldn't be very nice, okay? Facebook would probably sue me, and I would probably not be able to come back here at any time anymore. That's if I didn't end up in jail or something. So I just feel like I need to make sure you understand that I'm not really hacking your apps. I have managed to hack some apps, and all the apps I hacked, I made sure to contact the developers. So some of these apps I hacked, I got access to stuff like credit card information, for example. I got access to a 55,000 user base, 55,000 users database with addresses and everything about those users. So I could have done something with this. What I did was I contacted the developers and I said, hey, I'm not even a hacker, and I did that. Imagine what a hacker would do. The developer, unfortunately, never got back to me, but, you know, that's another story. But, so, if you see anything here, or if you see anything that resembles any of your applications, I'm not picking on you, okay? So don't sue me. Now, let's just talk a little bit about the hack I have just showed you here. So this little thing, like this little demonstration I just did here, which was, you know, me actually adding a man-in-the-middle hack into an application. But let's just talk about how communications actually work, like how applications communicate to the server. So usually you have an application that makes a request, and I'm really sorry that the stuff is like under here. So if people from behind want to move forwards, just so you can see it. But usually the way it works is a user makes a request to the server then replies to this request. So the server responds to that request with, whatever the user is asking for. However, what I just did here was I added a new character into this whole conversation, which was the man in the middle. So basically, when a user makes a request, the user doesn't really make a request directly to the server. The user makes a request to a third party, which is, in this case, it's just a proxy. The third party then makes a request to the server, and the server returns to the third party, and the third party returns to you. So as a user, you don't really see anything. As a user, you're still just making your normal request. However, there's this man in the middle intercepting every single one of those requests. So there's a man in the middle just getting information about what requests you're making and what responses you're getting. Okay? And this is really dangerous because, imagine your banking application, for example. If someone does that to your banking application, it means people now have access to everything that you're doing with your bank. A really good example of this was, who's playing Pokemon here? No? Okay, some people, I am, okay? So I have no shame in saying I am still playing Pokemon. I'm not as excited as I was, but still. So the way people actually managed to hack Pokemon Go was using a man-in-the-middle hack. Because Pokemon Go, they weren't smart enough to go ahead and protect the communications between the app and the server, which basically means some people who really wanted to catch those Pikachus went and hacked Pokemon Go app with a man-in-the-middle hack, which meant now those people get access to everything the app does and all of the requests this app does to the server, which means you can now do stuff like this. You can have those arrows and you can have those buttons, and you don't actually need to walk anymore on Pokemon Go. You just use those things and it walks for you, okay? Talk about laziness. But obviously what that does is it helps you catch more Pikachus, okay? Now, the interesting thing about this is this hack wasn't made by hackers. They weren't real hackers. They were just people who wanted to catch more Pikachus, okay? And if they could do it because they wanted to do that, imagine someone who wants to actually get your banking information. Now I'm going to move on to one really interesting story, and I feel like this story is especially particular to this crowd. Has anyone heard of Kuba Gretzky? Is Kuba Gretzky even here today? No? So you're not Kuba Gretzky, but you've heard of him. Okay, yeah. So Kuba Gretzky is a Polish developer who manages to hack a rewards application in order to get free beer. Okay? Now, before I carry on, I always like to show this, which is that is what the register thinks a Polish hacker looks like. So a strangely dressed man. I'm not sure this is how a Polish hacker looks like, so you guys probably can tell me. But as far as I know, that's not how they look like. But anyway, the way Kuba Gretzky actually managed to hack this application was via loyalty, which is super interesting. I'm not going to be mentioning the application name here, though, for reasons. But what he managed to do was, he had this loyalty app. Imagine a Starbucks app, for example, where you go to Starbucks and you buy 10 coffees, and every 10 coffee you get one free coffee, okay? His motivation here was very different, because his motivation was beer, okay? Kuba Gretzky realized that for every 5 beers you bought using the app, you would get one free beer. Okay, so that's simple. You buy 5 beers, you go to a pub or you go to a bar, you buy 5 beers, you show them your phone, they add you 1 extra credit, and then for every 5 beers, you get 1 free beer. Very good. So the more beers you buy, the more free beers you get, right? What he also realized was that every single time he used these applications, so every single time he wanted to use this application, every bar he went had one of those beacons here. Now, I hate iBeacons. But that's got nothing to do with this talk. I just wanted to kind of like take this off my chest. I really don't like iBeacons. But what he realized was that his app would make a request for an iBeacon. This iBeacon would reply with a message to the app, and then the app will know when to go to the server. So that's very simple, right? But how can you hack this thing? Well, if you've used an iBeacon before, you know iBeacons are not the safest thing ever, okay? He noticed that the information coming from these iBeacons, they weren't really encrypted or anything. The iBeacons themselves weren't encrypted, and he added an HTTP proxy. So he did a man-in-the-middle hack here, just like the one I showed you, where he was able to intercept every single one of the requests his app was actually making to the server. With that, he ended up with something like this, which looks really dark, and I'm sorry for this, but he ended up with something like this, which is the actual request his application would make, so his mobile application would make to a server. So you've got the URL on the top there, you've got a GUID, it's obviously going to /points because it's adding an extra point, and most importantly, there's an authentication token there. So now, he knows what the authentication token for that specific bar he should be using, so he gets more free beers. Not only that, he doesn't need to buy any more beers because he knows how his app actually makes a request to the server, so he doesn't need to buy any more beers. He also got access to some extra stuff, such as the information about the beacon. So if he wanted to start his own bar with his own beacon, he could do it now because beacons are not secure. So he had all the information about the beacons. He also had the information about the products. So he found that it wasn't just beer that you could get, but obviously he was interested in beer in this case. Okay, his motivation was beer, and obviously this is exactly what he did. So he started to get beers and get beers and get beers for free. And Kuba Gretzky got access to an undisclosed amount of beers. Okay? So he wrote like an entire blog post talking about this, which was really interesting because like he actually described everything, but he didn't say what the application was because he wasn't trying to, he wasn't trying to shame anyone. He was just talking about a security flaw. The only thing I know about Kuba Gretzky is this is the last time he posted a blog post. So this is the 18th of August, 2016. He's not blogged ever since. Okay, so. The reason I was asking if Kuba Gretzky was here today was like, I'm actually worried about this guy, okay? Has he been drinking too much beer? Did he get arrested? We don't know, okay? But let's just look at some of the things, and this is where this talk gets a bit more interesting, because let's just look at some of the things that the people who built the application could have done to stop this. Okay? Because obviously, like, I'm talking about, naming and shaming, like publicly shaming someone and say, hey, your app is crap, I just hacked it. But how can you actually fix that? What kind of things can you do to fix your application? So one of the things they could have done is they could have encrypted all the values, okay? And I say encrypt very loosely here because there are so many ways, like, I believe most of you are Android developers, and there are so many ways you can actually encrypt a string. You can even encode a string if you wanted to, okay? So in the initial example I gave, I was actually encoding the string. And yes, base64 is not any more secure than just a string, but someone looks at that, they don't know what it looks like, or they don't know what it is. If they're not a hacker, they may not go forwards. They just move on to the next application. But encrypting is like some encryption is better than no encryption at all. And in this example here, the Kuba Gretzky's example, there was no encryption at all. So reading through Kuba Gretzky's profile and everything, he's not even a hacker, he's a developer. But he managed to hack this thing because he really wanted to. His motivation was he was going to get free beer. And, I would probably hack an application for the same reasons. So just talking about encrypting values, for example, there are loads of libraries and everything that you can use to encrypt an application or to encrypt values in an application. Scott Alexander Brown, he wrote this library, which basically you just drop the library and then you end up with two methods. You've got an encrypt method and you've got a decrypt method. And you can choose what kind of encryption you want to use, and at least this gives you something, okay? Like, the reason I like to use this example is the footprint on this thing, like the footprint in your app using this library is very small. It's a very small library, and it's probably not gonna like trouble you too much to go and just go ahead and encrypt some of your values. And then obviously because you're using like AES encryption, you can decrypt it on the server, for example. Now, the other reason why you want to go ahead and encrypt your values is your keys are going to end up in GitHub, okay? Sooner or later, if you've got keys in your application, your keys are going to end up in GitHub. And this is a story about a guy called Luke who went and committed his keys to his GitHub repository. And these were his Amazon and AWS keys. And what happened was, in something like 20 minutes, he got a bill of $3,493. So 20 minutes that his keys were on GitHub, someone was able to realize that his keys were on GitHub. They went ahead and they spun up a load of VMs on AWS, and they started mining Bitcoins with it. That was 20 minutes. So what happens right now with GitHub is there's people scanning every single commit, because GitHub has an open API. So there's people scanning every single commit and looking for things like keys, passwords, authentication, tokens. So they're just looking for those things. And as soon as they find this, they go, oh, I found one. And they have things that automatically just grab those keys and like spin up new VMs, and those VMs start mining Bitcoins, and then you make no money at all because it's Bitcoins. No one makes money with Bitcoins anymore. But still, that gives you a bill of almost $3,500. Now, the other thing that they could have done is they could have utilized security features that already exist, okay? So, as it turns out, beacons, you can actually secure them. I still think they're crap, but you can actually secure them. You can actually encrypt information from beacons. So, they could have used that, but obviously they didn't, and Kubo was able to get everything he wanted from those beacons. He could have cloned the beacon, and if you've used the beacon at all, you will know that cloning a beacon is just a matter of opening the beacons app and changing the values. So it's not like you don't need anything special. You just open the app and you change the values. Like they're all like free for you to go and change. Now, the most important thing they could have used is certificate pinning here, because obviously what I just said was Kuba was making requests using his own proxy right now. So he was making requests from his own server. He was using his own SSL keys, okay? You shouldn't be able to do that, but you are if you don't use something like certificate pinning. And what certificate pinning really is you bind your application to your host. So you have an application, you have an SSL certificate in your server, and you bind them to. And what you do now is you say, I'm only going to accept, as a host, I'm only going to accept requests that come from this application. If they come from anywhere else, if they come from any other key, I'm not going to accept this. And if you use something like OKHCP right now, this is basically what it takes to do that. So it's what, 10, 15 lines or something? And what you're doing there is you're saying my host name, which in this case is publicobject.com, so it's just an example. Then you're saying, this is the key for my host, so only use that key, and then you just ping that key into your host. So you just say, hey, right now, any requests that make from this device, any requests that come from this app, will go, they'll only be accepted if the key is valid. So it's really simple, okay? And I know I'm using OKHCP as an example here, but if you're using any HCP library, such as Volley, for example, you get these, okay? So this comes with the actual library. The only thing is, this kind of information won't be on the initial README of the app. because not everyone will be doing this. Some people just want to make HTTP requests. Like for some people, it's not important to use certificate pinning, for example. Some people don't even use certificates, okay? And that's the other thing I want to talk about, because like, if you have a server, like if you have any servers, you need to make sure you have you need to make sure you have an SSL certificate. Like certificates are free now. You can go to Let's Encrypt and you can get a free certificate. Okay. If you have a business and you want to buy a certificate, it's about $20. Now the last thing I want to talk about this is do not trust the device. And this is a mistake that many developers actually make. They trust the device too much. And when I say do not trust the device, what I really mean is people can just go ahead and decompile your app, okay? So if you have information inside your app that you don't want people to know, you should probably not leave it inside your app, okay? Now, I'm just gonna show you. So this is one tool that helps you decompiling an application, okay? You will find like those tools freely available on the internet. You don't need to spend any money. You can just go ahead and download, and you get access to something like this. And this is how you go ahead about decompiling an application, which is not going for some reason. Okay. Oh, my thing just froze for some reason. Let me try and go back. Okay, I'll post that on Twitter later, because for some reason it's not, this one is not playing. Or is it going to play now? Okay, so it's not playing, but the idea with this one is you can go ahead and decompile an app. When you decompile the app, you can just get all the information from this app. You can get stuff like keys, you can get anything that is inside this app that is not encrypted. And this is why I say, like, encrypting is so important, and it's so easy to do, that you should just go ahead and do it. But then some people tell me, like, okay, but I need some magic strings. Like, I need to be able to store things inside my application, because I use APIs, for example, and when I use those APIs, they need keys, and I need to be able to pass those keys ahead. So there's a couple of things you can do to not have those keys stored in your application, or to maybe just make it a bit more secure. One of the things is, like I said, encrypt those keys. Don't have just plain text information inside your apps, because it's so easy to just go ahead and decompile it and just get the information. Like, it's no trouble at all. The other thing is, if you can, store this information on a server. Use a server, make an HTTP request to a server so you get your keys from there. And if you're using something like certificate pinning, for example, you know other people won't be able to make those requests. Okay, only you will be able to do that, so they won't be able to get access to your keys. Some of the things that you can start doing proactively, so some of the things you can go ahead and do, if you think your application is not secure by now, and I'm sure that some of the things I mentioned here, there will be people thinking, oh, yeah, actually, I'm not doing any of those things, so I should start doing those things. One of them things is add tampering detection. And tampering detection is, like, most developers don't even realize you can do tampering detection in your app. So you can now stop people from decompiling your app, or you can now stop people from, if they decompile your app, you can stop people from doing things with it. And I'm just going to show you a couple of examples here. And I know some people on the back won't be able to see this, but I have a very simple code here that checks whether an application is hacked, okay? So what it does is, it checks that the package name is the same as the one you created when you built the app. So this basically means if someone wants to go ahead and rename my app for some reason, if someone wants to go ahead and download my APK and rename it and try to republish it, I can tell the user, like, hey, this is not my app. Like, you've probably downloaded something else, or you probably downloaded something from somewhere that is not the Play Store, for example. A good example of this was back into Pokemon Go. When Pokemon Go was only available in the US, this really clever hacker went and downloaded the APK. By downloading the APK, they managed to decompile it, make some changes to it, and republish it. When they republished it, everyone who downloaded the APK was sending information to him. Okay? So he was basically trying to steal information from people, and he did that because people installed Pokemon Go. So the first one is, if anyone wants to like rename your application, you can give him like an alert saying, hey, this is not the application you're looking for. And this could be a banking application, okay? And this is why I think it's important. The other part of it is you can actually check who the installer is in this app. So you can check that the application actually came from one of the installers you trust. And when I say installer, I mean you can check that this application actually came from the Play Store. You can check the application came from the Amazon store and not from any other stores, okay? So if anyone wants to download your application, decompile, recompile it, and put it in an alternative store, you can actually do something about that. And what some people actually do is they make a request to their own server to say, hey, someone is using this app in a different store. And that's your chance to actually do anything, okay? So you can check whether an application has been relocated, and you can check who the installer is. Obviously, with the relocated, you get the added bonus that your APK will not work on an emulator, for example, because it didn't come from any store. So the installer will return null, and if it returns null, it means someone is actually trying to use this application in an emulator. And while it may make sense as a developer to use your application on an emulator, it doesn't really make sense. It doesn't really make much sense for users to use applications in an emulator. And in fact, 98% of all the hacks on Android applications come from an emulator, because it's the easiest place to do it. You can also check your application signature. Every single time you compile and release your application, you end up with a signature. And what you can do is you can check that your application, the signature in your application, is the same as the one that is actually in the application right now. So again, if someone was to try and decompile your application and compile again, the signature would be different. And if the signature is different, you can again do something like, hey, this is not the app you're looking for. You should probably go and download it from the Play Store. Now, check for rooted device. As soon as a device gets rooted, you can pretty much forget about all the things I've been talking about. Because when you root a device, when someone roots a device, most of the security won't work anymore. The one thing you can do is you can check that that device can actually execute commands. Okay? So if you can do exec su, for example, it means that device is rooted. And if that device is rooted, you can do something about that as well. You can say, hey, so I'm not responsible for what's going to happen from now on, or you're not going to use my app. My bank did that to me once, and it was really annoying because like I had a rooted device. I was accessing my bank, and my bank was like, no. You've got a rooted device, so you can't access it. And they did it in a way that even if I use something like hiding root, like the things you can use to hide your root, it wouldn't work. So you can go around those things. You can also check for emulator. So I said, if there's no installer, so on my previous codes I said, if there's no installer, it means it's coming from an emulator. But there's ways you can actually check if your application is coming from a emulator. Generic is the one that comes with, is the generic Android emulator. If you had something like Genymotion, it would be Genymotion. There's all the sorts of things for emulators, and I'm only using one example here. Like, one of them is even called Goldfish, and I don't know why that is, but one of them is called Goldfish. But you can check for emulators as well. And the last thing you can do is you can check if the application is debuggable. And checking if an application is debuggable is super simple. You just check that the debuggable flag exists, and if it's true, it means it's debuggable. If it's false, it means it's not debuggable. And that's the point when some people say, well, but if I release my app, it's in release mode, so that flag will always be false because I've just released my app. And hopefully that's going to play, maybe not. Yeah, I don't know why that's not playing. When you decompile an app, changing the application from not being debuggable to being debuggable is as easy as just changing the Android manifest over there. you have a flag that calls, in the application, you have a flag that is called debuggable. It's going to be set to false. You change that to true, and that's how you change an application from not being debuggable to being debuggable. And now you get access to a lot of things in this application because it's debuggable. You can see the logs, you can see everything. And this is also the points where people tell me, well, I don't know what to do now. Like, where should I start? The first place I usually tell people to start is, if you are not using ProGuard, you should be using ProGuard because it's free and it comes with Android Studio. If you create a new project today in Android Studio, chances are that you are using ProGuard. You are going to be using ProGuard. If you're using Eclipse, I'm sorry. But DexGuard is also a good alternative here. They're both from the same company. The thing about ProGuard is, well, it's installed by default. It does name obfuscation, so it obfuscates things like the name of your methods. It does code optimization, and it removes stuff that is redundant from your code, such as methods that you're not using in your stuff. So it helps you not hitting those 65,000 methods in this particular package or in this particular Dex. And then you've got DexGuard. DexGuard, as you can see, it's way more complete than ProGuard. So you've got stuff like class encryption, core hiding, string encryption. So you've got all these things on it, and it does certificate pinning for you as well. Like it can do certificate checks. Obviously, you're now wondering, why is that in Android Studio and why is that not? And the reason is that one is free and that one is not. So that one costs money. Yeah, so that one costs money. The licensing on DexGuard is complex, to say the least, because you can't just go and buy a license to DexGuard and say, hey, that's cool. DexGuard licensing works based on the number of users you have. So if you have an app that doesn't have that many users, then you pay some money. If you have an app with 1 million users, for example, you'll probably be on their top tier, and their top tier, it keeps on changing, but it can be, I've seen it costing something like 5,000 euros, I've seen it costing something like 4,000 euros, but that's the kind of money you're thinking about here. So I always tell people, use ProGuard and just add the things you want. Or if you don't want to bother with this, if you want it to do everything for you, just go for DexGuard. DexGuard does class encryption, which is really nice. It basically changes the name of your classes, and it changes the name of your methods using stuff like Chinese characters, for example. So if someone was to decompile your app and try to read the code, it wouldn't really make much sense to them unless they were Chinese. But you can also look at other things, like you can also look at the Safety Net API, for example. The Safety Net API has been there for so long, and no one uses it. But what the Safety Net API does is, it's free, it's made by Google, it's got support on it, and what it does is, it checks for stuff like, is this device compatible with my app? Is this device rooted? So it basically gets all the information about that particular device. It makes an HTTP request to Google. Google then returns saying, that's cool or that's not cool. The reason some people don't use it is because you now need to make an HTTP request. Okay, so if your app doesn't make HTTP requests, to ask for internet permissions is a bit weird. Like, you know, it's the, well, yeah, I have this really great flashlight application, but I need all your permissions. But if you are, or is he asking for this permission? I feel like using this is like the Safety Net API is a really good way to not have to do anything because it will do most of the things for you. The other thing you can look at is implementing network security configuration. Network security configuration does a lot for you. But the one caveat is it's only available in Android N. Okay, so if you're building for anything that is under that, this version of it would theoretically not work. Now, there's a guy called Mark Murphy who backported this to Android 4.2. And what network security configuration does is it adds you trust anchors, for example, which, again, is the certificate pinning thing. It does debug-only overrides. So if someone tries to change your application to debug, it goes and changes it back. It does clear text traffic. So if you have like a browser, if you have like a web view in your application, it checks for the URLs that you're actually requesting to. So if you're making a request to a URL that is slightly dodgy, it will stop it. And basically the idea is, if the users were to take control of your application to make requests to URLs that you didn't want them to do, this would stop it. So it checks all the URLs for you. And this is really cool. And again, this is free, okay? So Android 4.2 is obviously not what most developers are building right now. I think we're focusing on API 18 right now. But still, being able to do this in Android 4.2 is, I think we're in a good place now. Now, I kind of just want to close this by saying the internet is a very dodgy place, okay? Using applications or doing things without, like, people will do things to your app, okay? People will do things to your website, and the internet is not a safe place. But the thing is, when it comes to security, you really need to make sure you protect yourself. Because if you don't, people will do things to you, and people will do things to harm you. With that, I've been Marcus Placona, developer evangelist for Twilio. I will be around today and tomorrow, so if you want to ask me any questions or if you want to come and talk to me, please come and talk to me. And I think we're going to open for some questions now. Thank you very much.